Okay, grade 9, welcome to your answer video for your diagnostic fraction quiz. I'll reach back onto your grade 8 and 7 understanding of multiplying, dividing fractions, as well as adding and subtracting. The first question we have is a true-false question. It says 2.5 is equal to 5 over 2. If the answer for this is true, if we think about 2.5 chocolate bars, there's a chocolate bar, there's a chocolate bar, and there's a half a chocolate bar. So we have 2.5. How many halves would this be? Well, this one right here is a half of a chocolate bar. There's a second half of a chocolate bar, a third half of a chocolate bar, a fourth half, and a fifth half. So we think about 2.5 chocolate bars. It is the same thing as what we would call 5 halves. All right, so the answer is true. Question 2, we have 15 over 6 is equal to 2.5. Well, 15 over 6 is a mixed fraction. So if we think about something divided into 6 parts, there is 6 parts here. If I double that, can I double that? No, maybe not. If I double it, 4, 5, and double that again, there's 12 sixths plus an additional 3 sixths. Altogether, this would be 15 sixths, because each one of these is a sixth of a chocolate bar, 1/6. Now, think about how many full chocolate bars would that be? Well, there's 1 full chocolate bar, 2 full chocolate bars, and we have 3/6 of a chocolate bar, which we know in lowest terms would be a half. So therefore, we have 2.5 full chocolate bars. So our answer for question 2 is true. Question 3, 1/2 plus 3/5 is greater than 1. Now I'm going to say it's true, and I'm going to tell you why without doing any math. Some people actually solved it by writing the question down and finding a common denominator and blah, 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 blah. But here's how you can think about it without having to do the work. If you think about a fraction that is half plus another fraction that is greater than half, if you have half of something and you add a little bit more than half of something, will you have something that's greater than 1? Yes, you will. So that's how you could explain it. Half plus more than half is greater than 1. Question 4 is half times 3/5. Remember, if I translated this, this would be half, and the multiplication sign is of 3/5. So half of 3/5. These are the same thing. And if I take 3/5, which is less than 1 of something, and take half of it, it is impossible for it to be greater than 1. So therefore, half of any fraction that's less than 1 has to remain less than 1, and therefore it is false. Question 5 says 2/3 multiplied by 4. Now we're just looking for the algorithm or the procedure to get the answer. We always said that it's easier to think of whole numbers as being over 1, and then you multiply your numerators together and you multiply your denominators together to get an improper fraction of 8/3. How many 3's in 8? There are 2, with 2 left over. So as a mixed fraction, your final answer is 2 2/3. Question 6, a much easier question. There are 2 ways you need to be able to do this. So if you just multiply the numerators and multiply the denominators, you get 3 over 12, which we would know probably that that is not lowest terms, because you can divide both the numerator and denominator by a common number, in this case 3, leaving you with 1/4 as a final answer. But another way you probably learned in grade, I'm just going to clone this, in grade 8, was that you can cross reduce. So if I think about 3 over 4 multiplied by 1 over 3, I would multiply the numerators and I'd multiply the denominators, and I would get the numerator 3 and I'd get the number 12. But if I think about what if I swapped these numerators, what impact would it have on the net result? Well, if I swapped the numerators, like I put the 1 over here and the 3 over here, I'd end up with this equation. And if I think about this equation, I would never have multiplied by 3 over 3, because 3 over 3 can be reduced down to 1 over 1, and I would have ended up with a product of 1 over 4. So in this particular case, what we could do, instead of actually physically swapping the numerators, I could put my lines through there, and just like I did here, reduce that fraction to 1 over 1. And then when I multiply the numerators, I got 1 times 1 over 4 times 1, which gives me the answer of 1/4. And what I ended up doing is I just skipped this step right here, which is reducing. So either way you look at it, your answer is 1/4 in lowest terms. Question 7, we have a whole number multiplied by a fraction. So again, just like we did in question 5, we're going to consider that whole number to be 4 over 1, multiplied by 3 over 4. When I multiply the numerators and multiply the denominators, I get 12 over 4, which will reduce down to 3 over 1, which is simply the whole number 3. The whole number 3. But if you remembered what I said before, if I cross-reduce this, that 4 over 4 will reduce down to 1 over 1. And now when I multiply the numerators and the denominators, I'm just going to get 3 over 1, which is 3. So either way you did it, you end up with the whole number as 3 as the product of those two fractions. Question 8, we're switching back to grade 7 now. It's the addition of fractions, and the difference between addition and multiplication is quite significant because addition is a little bit more labor intensive, because in order to add two fractions together, you first need to make equivalent fractions that share a common denominator. So the first thing we really have to do, and a lot of these people do these without even thinking about it, is I have to think about all of the multiples that 2 and 5 share. And if I look at the first one they share is the number 10. So what this means is that number 10 is the first multiple they share, and therefore can be used as what we call the lowest common denominator. So we're going to rewrite this addition statement as equivalent fractions that have that 10 denominator. So this first fraction, 1/5, is equal to how many tenths? If you think about creating this equivalency, you learn that you multiply by a common number to create equivalent fractions. So 2 over 10 is equivalent to 1 over 5. Both represent 20% of something. And this 1/2 is actually 5/10. Both represent 50% of something. So now that you have that, our algorithm is to add the numerators together and keep your denominator. And your final answer is 7/10. Question 9, the only difference between these two is you're adding mixed fractions. Now, there are ways to do it. You could take your 1 and take it out, and then add 3/4 and 2/3, in which case you would get a common denominator of 12, equivalent fraction of 9/12, equivalent fraction of 8/12, that would be 17/12, which is 1 and 5/12. Bring back in the one you brought out, and your final answer would be 2 and 5/12. Alternatively, you could have just said, well, I'm going to convert any mixed fraction I see into improper, which is 7/4 plus 2/3, and then just work your common denominator this way. Would be 21, right? And would be 8. Would be 29/12. How many 12s in 29? There's 2. That's 24/12 plus the remaining 5/12. You get the same answer, just a different way. You can convert your mixed fractions to improper, but still use equivalent fractions, common denominators, etc., etc. Question 10 is subtraction of mixed numbers. Now, this one does not work well with the whole numbers first because you might end up borrowing, and it's not very good. So if you change this to a mixed fraction, 2 times 4 is 8 plus 11/4 is equivalent to 2 3/4. Take away 15/8. So now we have the same question except written as improper fractions. Common denominator will be 8. This won't change, but this will. Once you get it down to equivalent fractions with common denominators, subtract your numerators. Keep your denominator, and your answer will be 7/8. Question 11 is division, and there are ways to do it. You could find a common, you could do 3/4 divided by 4 over 1, and then make common denominators, etc. But we learned in grade 8 that the easiest way to do a division is to keep the first fraction and multiply by the reciprocal of the second. Now, the reciprocal is simply the flip. So if you have the number 4, you got to think of it as being 4 over 1, and therefore you'll know the reciprocal of 4 is 1/4. Once you have it written like that, just multiply your numerators and multiply your denominators, and you end up with the answer of 3/16, right? For question number 12, you're going to keep 4 over 1 divided by 3/4. But remember, keep the first fraction, change to multiplication, and use the reciprocal of the second fraction. So I just have to swap the numerator and denominator. The reciprocal of 3/4 is 4/3. Multiply your numerators, multiply your denominators, and you get 16/3, which is 5 and 1/3. Question 13. a division again, so keep your first fraction, change to multiplication and use the reciprocal or the flip of the second, which will become 11 over 6. Now when you're multiplying these, you could do, of course, multiply the numerators, so 6 times 11 over 7 times 6, which is 66 over 42, which reduces to 33 over 21, which is 1, and 12 over 21, which will reduce down because both can be divided by 3, to 1 and 4 over 7. Now alternatively, if you got down to this part, you're like, hold on a second, I can cross-reduce this. 6 over 6 reduces down to 1 over 1. Then I got 1 times 11 over 7 times 1, which is 11 over 7, which is 1 and 4 sevenths. A much easier pathway than if you didn't cross-reduce. But your answer is still 1 and 4 sevenths. And finally, your last question is a Bedmass question, 1/2 plus 4/5 times 3/8. So I'm going to do the multiplication first, which means I'm going to bring this down. If you're multiplying fractions, you can cross-reduce. So 4 over 8 will reduce down to 1/2. So now multiply 1 by 3, you get 3, and 5 by 2, you get 10. So once you do the multiplication, you get 3/10, or 12/40 if you didn't reduce it. Find your common denominator of 10. First fraction, 3/10 stays 3/10. This becomes 5/10. Either you're adding, add your numerators and keep your denominator, you get 8/10, which in lowest terms, don't forget, if you have 8/10, check to see if you can divide it by any common factors. You have 4/5 as your final answer.